Alright everyone, in this video we're going to take a look at some GDScript optimization tips. Alright everyone, in this video we're probably going to have some code or something going on in the background, just to show you a bit of an example of how you would maybe use some of these as I just kind of talk over it. And well, let's just jump into our first one. Alright, so first up, we're going to go ahead and talk about object pooling. Now, what is object pooling and why would you use it versus just creating and constantly destroying your objects? Well, object pooling is a software design pattern that is typically used to improve performance in different computer programs, which of course is what your game is. Your game is going to be a computer program at the end of the day. Now, the idea that's behind object pooling is to reuse an object from a pool of available objects instead of instantiating new objects every time you need one. So an example of this would be if you're creating, say, a bullet hell, for example, where you have maybe like 1,000 different bullets, I guess we'll call them, on screen at a time from the player, and then you might have others from all your other different enemy types or bosses, and you have all this stuff going on, and then your game starts slowing down when you start getting that much happening all at one time. And the cause of that comes down to your projectiles, the bullets that you're shooting. And more specifically, in computer programming, when an object is instantiated, so every time you're creating one of these bullets, these projectiles, memory must be allocated to that specific object. Now, when an object is no longer needed, when we queue free it, that memory is deallocated. These processes are, at the end, are time consuming, and they can lead to performance issues that you may be experiencing. When this is done frequently enough, we have all this overhead, and it just keeps stacking up, and it causes our frames to take longer and longer, or spend longer and longer times per frame, which is causing that lag and performance issues. Object pooling reduces that overhead of having to deal with memory allocation and deallocation by reusing the same objects from a pool of available objects instead of consistently creating and destroying these objects. Now, instead of destroying an object when an object is no longer needed, what we do instead is we return this object into the pool of available objects instead of just its complete destruction and messing around with the memory again. The next time an object is needed, we simply go back into that pool and we grab one, instead of, again, having to reallocate memory again for creating a new object. This will improve performance by reducing the amount of memory allocation and deallocation that cause these performance issues, which in turn also reduces the amount of time that is spent to create that object. So really, by doing object pooling instead of constantly creating and destroying an object, especially if it's one that's going to be using consistently, we're removing all of that overhead, and you'll see a performance increase, especially, again, if you got something like a bullet hell, where you just have tons and tons of bullets going on screen and being destroyed and having all these calculations going, and you have all this stuff going at the same time. So object pooling, something that you can use to help speed up your game. Alright, let's jump into the next one. Alright, if you guys are able to see the screen, ignore the red bar at the top. That's just to move that error out of there, because we do have two functions with the same name that it will yell at us for. But next thing we want to do here is we want to avoid using the get functions, especially inside of or particularly inside of our update loops. So this includes things like our getting the position in our physics process, or repeatedly doing something inside of the process function like this, where we're constantly getting a set piece of information. Now in GDScript, the get functions are used to retrieve a value of a property or node, and when these functions are used in update loops, they're called repeatedly, which can negatively impact on the performance. This is because every time the get function is called, the system must retrieve the value, which it takes time to go in there and get that, bring it back, and then do whatever it is you need to do with it. So when the get functions are used in your update loops, they can slow down the performance of your code by creating these bottlenecks. The more times the function gets called, the more overhead is created, and thus the more your game begins to slow down more and more, or in some cases may even be completely unresponsive. On the other hand, storing the value of a get function in a variable outside of the update loop will increase that performance, because we're not doing this consistently over and over. We're getting a piece of information and storing it, right? We're basically like caching that data to be used at a later time. So something better for this is like you're seeing there on screen, where we get it in the ready function and that's it. We store that information to use later. Or better to do that in maybe a signal call that happens rather than the update function. On the other hand, storing the value of the get function in a variable outside of the update loop can greatly improve performance, as we just said. By doing this, the value is retrieved just the one time and then stored within that variable that we can use later. This fully eliminates all the overhead created by constantly calling and trying to retrieve that specific piece of data over and over and over. So you always want to avoid doing this inside of your update loops. Do this outside of them. So make sure that they only happen the one time, and set your data. Use that data when you need it. And in the example you're seeing on screen here, the get position function is being called repeatedly, as we see in the bad example at the top, which can slow down the performance of the code. You may not notice it with something small like this, but when you start getting a lot of things piled up like this, where you're constantly getting all that data, that's really going to start slowing it down, and where you'll really start noticing. So to avoid this issue, you can store the value of that get position, like we're doing in the good way here, in our variable outside of that loop that we can use later. And by storing that get position variable outside of the update loop, we reduce the number of times that function gets called, overall improving our performance, since we got to do less things on every single frame, right? Alright, so there's our next tip. Let's move on and see what we have next. Alright, on screen we're seeing again another good and bad example here. And with here we're looking at arrays and dictionaries, and we want to use these judiciously, or you want to make a good judgment call on which one to use here. And the reason for this, of course, is, as we know, performance in games is a critical factor on whether it can make or break a player experience. Obviously, if a game is laggy, you're not going to want to play anymore. Or if it starts lagging after you get so far into a game, or your game becomes so big, you're probably not going to enjoy it as much. Probably stop playing it, or just completely start a whole new game and lose all the progress you made. So what's one way that we can avoid doing this, or avoid our user having this kind of experience? Well, in the first example, or the bad example section, we're using an array to store items. This array can be updated frequently, with items being added and removed, and this will, of course, result in frequent additions and removals from the array. Now, the problem with this is as the size of our array grows, these operations tend to become slower and more time consuming the bigger they get, which will negatively impact performance because the longer it takes, the more time you're spending per frame or per action, which overall slows the game down. So if you know that you're gonna have a large set of data like this for your array, then what we want to do is actually move more into we're going to move to the good example section there, where we're using a hash table or dictionary, would be what GDScript calls them, and instead of an array to store all of our items. This data structure is typically offers better performance for large data sets, since it should have a constant time complexity when it comes to adding and removing elements or the items from it, regardless of how big the structure gets. So what this means is that even as the number of items in the hash table or dictionary grows, the performance of the game should remain consistent, which avoids, of course, your slowdown and the negative impacts that a large array would have. Which, of course, like we said at the beginning, those negative impacts from large arrays may cause the game to slow down, which gives the player a bad experience, which makes them typically want to stop playing, restart the game, or just kind of leave your game in the dust, which ideally, of course, we want to avoid. So make sure to think about what you're going to use that data for, how big it's going to get, and go ahead and make a judgment call whether you really should use an array or if maybe the dictionary route is going to be a better option for you in the long run. Alright, in this tip, we want to look at minimizing the use of calculations and transformations inside of your update loop. Now, performing calculations and transformations in update loops can greatly impact your performance, as we briefly went over previously, but especially if they're performed repeatedly, just like with our get function where we're calling that over and over and over every single frame, instead of storing that for later. Now, to minimize their impact, we can perform these operations it's best to perform these operations as infrequently as possible. So an example here in the bad code, or our bad example, is we're performing these rotations on all of our nodes inside of the group named enemies every single frame. This can, of course, result in a significant performance hit, especially if there are many nodes in the group. If we have a lot of enemies in this case. Now, a better approach to doing this same thing, remember we want to make or perform these calculations the least amount of time as possible. So instead of calling this for every single enemy within that group, what we're going to do instead, in our good example, is we're going to take a rotation, or we're going to take our rotation variable here, and all of them should be essentially rotating the same amount. That's essentially what we're getting to here. And what we're going to do is we're going to perform that calculation that we want to apply to all of those nodes. And we're storing that inside of our rotation variable, which we can then use to apply to all of the nodes inside of our group with a single call of rotate. This results in much fewer operations. As you see there, all we're doing was saying rotate by this amount. We're not saying, okay, all enemies or everyone in this group perform this mathematical calculation and then go ahead and rotate each individual axis by this amount. Because with that, we're performing 3 calculations per node that's inside of that enemy group. Whereas in our good example, we're performing 3 calculations and that's it. So if we have even 4 enemies in that group, we're doing 12 calculations in the bad example versus the 3 calculations in our good example. And that's going to remain that same way the entire time. So if we had 100 enemies on screen that have to rotate, we're performing 3 calls here versus 300 calls. Or 300 calculations, rather. So you can see how this can quickly add up to more and more objects that you get within that group for this massive or this big wide call that we're trying to do with these calculations. Alright, let's jump into the next one. Alright, so for our last tip for this video, if you have no idea what is causing your slowdown, you don't know where these bottlenecks and problems are coming from, make sure to profile your code and look for those bottlenecks so you can focus on where to optimize your code. Profiling your code means to measure its performance and identify which parts of the code are taking the most time to execute. Now, this information is extremely valuable when optimizing your code because it helps you identify that bottleneck or the parts of the code in general that are slowing down your overall performance. To profile your code, you can use tools like the profiler that's built into the Godot Engine, or you could use an external profiler such as Perf or Valgrind. These tools measure the amount of time each part of your code takes to execute and provide detailed information about that performance. So looking at the example code that we have on screen here, in this example code, we perform an expensive operation 10,000 times every single frame. To profile this code, you would use a profiler to measure the performance of our perform expensive operation function. The profiler would then tell you how long it takes to execute and where the bottlenecks are. So with this information, we can then focus on optimizing the bottlenecks to improve the performance of our code. For example, if the bottleneck is the calculation of result, you would consider using a more efficient algorithm to perform that calculation. So let's see what we get when we actually run this code ourselves. So if you're going to use the built-in profiler, you just go into the debugger tab. And typically you'll be here. You want to open up Profiler and hit this start button before we even begin. And go ahead and run your scene. Give it just a few moments. I'm going to have to open up Debugger and go back to the Profiler section. And just let this run for a bit. Alright, we've given it a bit. If you notice in the top right of that debugger, we can see we haven't even hit the 30th frame yet, so this is not looking good. We can go ahead and stop running that. Open the profiler back up. Our data is still here. And we could come all the way down. In this case, it is the last option here. And turn on or check off script functions. And because of this, we can see the physics frame is 16.6 milliseconds. That's perfect. That means our physics frames is running at 60 frames a second, and to get that number, you would just do 1 divided by however long or whatever your FPS for your game is. So 1 divided by 60, 1 divided by 120, 1 divided by 144, 1 divided by 30, etc. And that's the number that you should be looking at there for our physics frame. 16.6 is 60 frames a second. But our frame data, we can see, is taking 838 every single frame. That is huge. But it's obviously not our physics frame. We're taking a look. It's our processing time. Okay, well, that's interesting. So it's something inside of our process function, right? Our update loop that we got going on. And what do we got going on there? Well, we have script functions. So with that turned on, we can see inside of our process, That is certainly what's causing it. And more specifically, it is our expensive operation. We can see we're calling it doing 10,000 calls. Now, that on its own, maybe that's your issue there. Maybe you just need to find a way to reduce your call amount, or find a way to not make as many calls, not make sure that you're not making calls when you shouldn't be, whatever it is. Or it could, again, come down to just coming up with a completely different algorithm here. But as we can see here, we can see that function specifically is taking up how much time it's taking, how many calls are being made. And if we were to click along in our section here, we can see this number is going to change. But that's the general idea of how you're going to use this profile to find out which part of your code is causing your bottlenecks. Alright, hopefully some of these tips help you with speeding up your code, whether you're making an application, software, or a video game. Alright, take care, and I'll see you guys in the next one.